Swayam Prabha. Digital India. Educated India.
So look at the ease of storage cluster. Remember these other ideas? This, turning idea, the folding idea, the Greek helmet idea. In this, the student somehow selected, the receding idea, amalgamated these two, and he didn't take one idea together. He said that I would like to make it very slim. So he started with this, which is part of the receding idea. He chose that as a champion and then, took it forward from here. See how the ideas were developed by using other ideas putting together. And then came up with this, where you press and you push the both shells inside and becomes very narrow. This is the ease of storage idea. And then comes the ease of use cluster. Remember the ideas? This idea, those ideas, all put together. And finally, this was taken as a champion. This idea was taken as a champion because this has, you just put like a cap and push it down, right? It's much more easy to wear. So that was considered as the main idea. So this is further developed because the net is too large, there are a lot of gaps. It won't, be acceptable as a helmet. So those gaps were reduced. So here you can see how the net is becoming smaller and the helmet shells are becoming larger, but still that whole idea is going inside. And finally, you can see the concept building into a concept C, which is the ease of use. So your three concepts. That competition between the concepts is a very, very critical thing. And from these three concepts now, we need to find out which ones will we use for the current product brief. Product brief was very, very clear. You would have encouragement of use. You should have, basically good storage, and you should have good ventilation also. So all the three can have all the three in three different degrees, right? First one is very difficult to store. It's still large. Whereas this one is easy to store. It's ventilatable also. This one is easy to store. It's ventilatable and easy to wear. So automatically, the last one got selected as the concept to go forward. And then we went to experts and asked them, what do you think about this helmet? They said, horrible. Who would want to wear a helmet which is broken from the beginning? Isn't it an interesting perception? This is the first reaction from the scientists and the engineers. Is like, this is like broken helmet. You're designers, you should have a perception to make it look strong and not broken. So then, the Dr. Dinesh Mohan, again a professor, he said, this is not going to work. At least make it two-part receding. Then we reworked the whole design, made it two-part receding, and so that the gap is also hidden, and it only collapses when you need to store, and you don't, see the break very, clearly, and different sketches were made. And this is how the first conception came up of what the helmet should look like.
So does the brake sacrifice structural integrity? Like in a collision, would it cause more damage?
So just tell me, will the brake compromise on the structural integrity of saving a person's head?
Brakes will make it will absorb more shock.
It will absorb more shock because you're getting closer to your head. The snug fit helmet is the best helmet for saving your life. And when the hit happens, it doesn't happen. Something is not hitting you all around your head. Got it? Whichever side you hit, it gets closer, and the fitting also is much better, and you get much better protection. And that's very counterintuitive, right? So you got a much bigger task of convincing users. That's better than the other one. And you should do evaluation by doing testing also. So here we have one of our Mandar's friend wearing the helmet and showing how the helmet works. And this is called the first working rig. Working rig will not be aesthetically pleasing. It will be built by using existing helmet parts. So he took three large helmets, chopped them, and created a helmet which will collapse, right? He doesn't have the, and then, showed us how the thing works. Use the same buckle. He didn't even use an elastic buckle. It's supposed to be elastic, right? That's why it's a rig. It's not a mock-up. When you use a mock-up, what will happen? It will not work, but I can wear. It won't collapse, but I can show. I'll show you a mock-up also. This is a mock-up. When it is full, this is the helmet. When it is collapsed, this is the helmet. It doesn't work, and the volume becomes nearly, reduces by 2/3, 1/3, sorry. So you have mock-ups. This is a scaled mock-up. You can have a full-scale mock-up, which I have some in the lab. We actually have an innovation studio. When the student finished this project, we want to carry this project forward, and we took it up in the Shenoy Innovation Studio, and we started working on this by now experienced designers, experienced engineers to take this forward. When the student does their juries during their final presentation, they have to show one photorealistic rendering, which is the actual shape of the helmet, the form and style. Either show a working rig or a mock-up model, full-scale mock-up model. Please make a very good photorealistic mock-up also, which is as close to the mass manufactured product, because nobody should be able to change your design intent later on. Now we are back to the Innovation Studio. So Innovation Studio is a professional organization, right? It's not a student body anymore. We got experienced designers who are 4, 5 to 6 experience. We got engineers. We use a lot of consultants from outside to work with us whenever we have problems in any of the materials and manufacturing and tooling. Remember I was telling you, one helmet doesn't fit all. So we said, whom are we working for? So they came up with a persona, an office-going person that has the largest population of people who are using two-wheelers, and they have, the maximum problems. So we chose that persona, and this is that persona. Then we found out their, daily routine, the average distances they travel, the type of vehicles they use, the type of shoes they use. So get the whole demographic information about this persona so that you're now clear about your segment of the user. So with that segment of the user comes the very important task of showcasing the features of your helmet. So remember, we were telling that the helmet will have a very good strap, which is elastic in nature. There's no buckling. It has a duct detail so that the breeze will go in. Remember, each concept has to have all the features. So the breeze goes in and comes out. So it keeps the head cool. There's an adjustable clamping system. So the elastic is not too hard on your chin. So you adjust using the clamps, which will take all the details of that. Then you have these vents, which will take care of all the ventilation effectively. Then you also have this very interesting rubber. This rubber is very important, right? Because if it's raining, the water should not go in, but it should also collapse and open up. So the rubber detailing is very critical. So these are the initial sketches of the rubber detailing. When the helmet goes in, how will the rubber sort of become straight and the helmet goes in? And when you push it out, how will the rubber block the gap? So this is a very large working, and we nearly spent 3 months working on this one detail. It is that tough. When you have a nice concept, it's easy to say, okay, it will go in and come out. But when you have a rubber detail over there, how will the rubber work? And the biggest challenge was the thermocol. Can I have a straight cut in the thermocol? I can't, because that area will be weak. If there is an accident in that corner, the person will die. So we need to have an overlap, and at the overlap, the distance is minimum 22 millimeter at all the lengths of the overlap. So once you do an overlap, then the helmet was becoming very large. So multiple problems, but these are all the features which the helmet had to carry. So then came all the product detailing aspects. How will you detail out? How will you rivet? How the shell will go in and out? The head dimensions, the control dimensions. How will the dimensions work? What are the other critical things? And these are generally designer doodles are very important for you to articulate and come out of your thought process. So this is called externalizing your thought process. When you sketch, for example, when you sketch, he's looking down, but when you sketch, you externalize your thought process, and then when you resketch again, you see the number of lines. When you resketch again, what happens? You are internalizing and externalizing again. So the doodles have a very important creative journey in any design journey. So then we did all the detailing of how will the thermocol shell work, what type of shape, what type of plastic covering should come on it, and how will the plastics break and lock into each other. Remember, this plastic shell has to lock into this plastic shell, right? So how will the locking happen? Will it be very wobbly or loose? Remember, one of you was saying it can be more dangerous if it's not good enough. That will go and pierce your head. If your helmet is not, if you have too many ribs, that can go and hurt you. So you're not, as per IS standards, you can't have any, projections inside. So you have to be very careful in all your detailing of how your detailing will be done. So all these, sketches are all about detailing. and taking the mock-up model, remember we had the design solution, to the next level of product development. And then the biggest challenge was, how will your top be buckled to the bottom? See, you have the top shell and that has to be buckled to the bottom shell. This aspect was, thought of multiple times. Should this shell be connected to this? And then this should be connected to the chin. That's one option. Second option is the top one should be connected to the strap and this should be connected to the top. You got it? Because the top should be tightest. So this is connected to my chin and this fellow is just hanging over there with the top. That's one option. So you have multiple options of thought. So this is another very, very big challenge of strapping. How will you strap the helmets was also a very, very challenging task. This also took a lot of time. Nearly how many years? It took nearly 2 years to come up with, to sort out all this. And then came the final design details. You can see how the thermocol has slots, how the strapping. So finally what we decided, we're strapping from the top, right? We're strapping from the top through the thermocol that's coming, then strapping from the bottom is hanging there, and hence your buckle is very. So this is at one stage. We have multiple stages of development. This is one stage of development. And after this stage of development, Mr. Chari, who was our own alumnus with a lot of experience in industry, again, went out and joined another company. And then we had another designer who joined us called Ashish. So Ashish now is a MDes from Indian Institute of Science, was sitting continuously on this product for another 1.5 years. So remember I was telling you, every idea which is creative and which is good for the user can be detailed out to become a good concept. So that was a very strong belief in me. I said, I'm not going to leave this. If collapsing is going to solve my problem of both ventilation and ease of storage and ease of wearing, I'm going to leave no stone unturned to see to it that this is implemented from multiple levels. The materials used, the technology used, the manufacturing technology, we'll do everything to take it forward. So we then did the digital sculpting to get all the shapes right. Now the very important aspects start happening. Remember, when you see this helmet wore on a head, you won't see the brake because it's on the top, right? So we had to take this cut inside. It is no longer outside. Remember the earlier helmet, the cut was outside. You can see it. Now the cut is inside. So user perception was also a very, very important aspect for us. We took that and then we got all the detailing done. We went back and did the strapping to the bottom section. So we did strapping to this one and attach this to this one. That was a much better idea. Because when you pull this automatically sits. And finally, this is one of these stylized versions which we couldn't fabricate because the thermocol was not fitting in. So this also had to be rejected. And then, we built the final option where with the step coming in, and with that step we used 3D printing machine very creatively, vertically, to make both the shells of the product. And with this we came up with the option of the rib and the support structure and how for example the volume of travel which will happen inside. And we also checked the thermocol, how it will go in. So this is a final redesign option with the visor of the total design, which had all the components of the collapsing, the ventilation, and the visor is a very important component anyway. And this is the final detailing of how the whole product was made with all the clamps, buckles, rivets to put all the parts together. And from the CAD model, we did multiple 3D prints. There would be an error over here, so we'd print again and join that. So in this case, this is the bottom shell, and then we also have the gasket 3D printed. Unfortunately, the 3D printed gasket was not very good, so it became very tight when we assembled it. Some of the components are very difficult to 3D print because the hard components are very easy. The flexible components, generally it is good to mold them. They're available in the market, we'll mold them because the molding cost is not very high. For example, the tool cost for this part could be as high as 8 lakhs. Whereas the gasket tool, would just be 2,000 bucks. So it's good to, do the gasket in real and do this as 3D print for your trial purposes. And after that, you can, take, things can go forward. And then, we came up with the final version of how the collapsed state, what type of volume it will occupy. Then we also see that it forms like a little small rectangular space, so it's easy to put in a bag. So you can go into a bag which is like a slot, or you can put on a rack. So multiple, advantages come in. And we also want to have ventilation from the top. So if you lift the gasket, ventilation ports are available for air breathing in. So these are the, designs which came up as the final design. I think as of now in this design, we kept the visor fixed, and it can be, it can be actually swiveled up. But actually, if you remove the screws, it's removable. So if somebody wants to buy a helmet without the visor, they can buy it. So that is that type of option currently available. But we thought when we did the survey, with the mock-up models, everybody said that they would need a visor.
Okay. Also, did you consider space for spectacles?
Yes. So that was a very important component. So where you can see the type of visor just coming out so much. So if you see the model, enough room is there. The visor comes out like that. So this is the first prototype we made and we tested by wearing. Look at the distance, pretty large, the visor. So then what happened, then we integrated the little cap type design with the visor. So this is the visor, where, the cap was integrated, still under progress. Making the transparent 3D printed parts are very difficult. So we are not able to get in single component. So we actually did this 3D printing and we'll be using a transparent gasket over here, but still doesn't exactly mimic what you want. So we plan to mold this, finally to get the visor right. Our another idea was, can I just snap on the visor and whenever I want, I snap it on and I take it out. So this also, has this elastic for wearability. So it's easy to wear. So, but it has a special purpose to, the way you have to wear, you have to be trained to wear it. So this is very critical. So we were just wondering how, because if you wear it with an elastic, it has to be coming from the front. So we are trying to see how we can, integrate that as a convenience of wear. And, opening also has to happen like this. So we are trying to, block it and, see to it that it's always blocked over here. So when you're wearing, you have to put your fingers in here and wear. So it's always locked like this, locked like this. So that is still working out. So that's one. And then, it collapses inside and becomes like this much. If the visor should have been there, if the visor is there, the visor would open up a little bit, and also because visor is from here to here. Now this has been gone into the visor, so it will open up and it will become this close. The gasket is made of either EPDM or we can use polyurethane, and it's also injection molded. You can use engineering plastics, which is like polycarbonates and ABSs for motorcycle racing. But if you're doing your regular work, which is here, it can be, a simple blend of ABS, which will be much stronger. So these are all two more injection molded parts. The thermocol shells are made of, expanded polystyrene. You'll have, so here my challenge is, remember the earlier helmet had only 2 dies. I have 4, 2 plastic dies, 2 thermocol dies, 1 visor die, and then the elastic strap. In fact, I must give you a good example over here. Did I tell you about this example of the VIP luggage company? The VIP luggage company, there is, my senior from IDC who is the head of the vice president now, and he's based in Hong Kong to source all the components. Because if you're in the world market in luggage, you have to have the components and the ecosystem at a level which is common with the world. The zippers, the plastic trims in the luggage, or the polycarbonate shells have to be at that level. So that's a very important understanding for us, that to innovate, you also have to have an ecosystem around you, which will work very effectively to take things forward.